Okay. So now, let's have na linear momentum, ano? So the linear momentum, or in short is momentum, of an object is defined as the product of its mass and its velocity. Okay? So momentum, or plural is momenta, no, from Latin, is represented by the symbol T, okay, with an arrow. So this signifies, or this denotes that our momentum is a vector. If we let m represents the mass of an object and v as the velocity, then its momentum p is defined as, so p is equal to m times v, or the mass or the momentum is equal to mass times the velocity of that object. Okay, so any object that has a mass and has a velocity, or any moving object has a momentum. Okay, so also momentum is just a measure of how hard an object moving to stop, how hard the object moving to stop. Okay, so for example, a moving object a certain velocity, no, v1. Okay, syempre habang tumataas yung mass nito, tumataas ang iyong momentum. Okay, mas lalong malaki ang impact niyan pag tumama yan sa ibang object. Actually, momentum is this focuses on object that has, or that is colliding, yung mga nagbubungguan na object. Pero dahil sa simula ng ating lesson, so an object that is moving, no, of a certain velocity, meron daw yung momentum. Okay? An object that has a mass and velocity has a momentum. Okay? So, nasabi ko kanina, it is a measure how hard a moving object to stop, is a measure, So, force is required to change the momentum of an object, whether to increase the momentum, to decrease it, or to change its direction. Newton originally stated his second law in terms of momentum, although he called the product mv the quantity of motion, para amount daw ng motion, sabi ni Newton. So Newton's statement of the second law of motion translated into modern language is as follows. So the rate of change of momentum of an object is equal to the net force applied to it. We can write this as an equation. Bali ito kasi original na statement ni Newton. Yung net force daw na in-apply natin sa isang object is the rate of the change in momentum for a certain period of time. So we have now net force, okay, is equal to delta P over delta T, wherein delta P, that is the change in momentum. Kanina meron tayong P is equal to M times V, di ba? So ngayon daw, yung ating force or yung net force applied to an object is equal to the change in momentum over time. So we have the initial velocity, no? Tapos ito yung final velocity. Okay? So kapag ka nag-negative to, ibig sabihin yung force na in-apply dun sa isang object, kailangan mag-negative to. Yung ating force or net force. Ibig sabihin nun, mas mababa yung velocity or yung final. Di ba? Kapag bumaba yung final, ibig sabihin, nag-apply ka ng force para bawasan yung speed ng isang object or velocity niya. Or, the force applied is in opposite direction of the velocity, kaya siya nag-negative. Also, dito galing yung second law na mass times acceleration, di ba? The summation of forces or the net force of an object is equal to the mass times the acceleration of that object. Okay? So, kung naalala to, yung equation na to, so from second law, so, di ba dito, factoring out m, kasi kung same object lang din yan, parehas lang yung ating mass. Okay? So, factoring out m, so we have v2 minus v1. Okay? So, itong v2 minus v1, that is delta v, or change in velocity. Alam natin that delta v over delta t is also equal to acceleration. Therefore, we have m times a. So, dun lang din nag-originate yun, yung ating summation of forces is equal to the mass times its acceleration. Okay? Or the net force. Okay? So, dahil dyan, solve muna tayo para mas maintindihan natin. So, okay. So, first example. Okay. For a tennis player, for a top player, a tennis ball may leave the racket on the serve with a speed of 55 meters per second, about 120 miles per hour. If the ball holds a mass of 0.06 kg and is in contact with the racket for about 4 milliseconds, estimate the average force on the ball. Would this force be large enough to lift a 60 kg person? So, meron daw racket, no? Meron tennis player, papaluin niya ngayon yung bola. So, paano bang ginagawa natin, di ba? Itchin ng tennis player yung bola. Sa serve niya itchin muna niya yan. Di ba? Ito yung bola ng tennis. Pagandahin nga natin. Di ba? Ayan yung halimbawa yung tennis ball. Tapos, titirahin daw ng raketa. Titirahin gamit yung raketa. Raketa yan. Ganda natin drawing. Okay. Titirahin ng raketa. Titirahin ng player ng gamit yung raketa, yung bola. Okay? So, ang mass daw nito, ng ating tennis ball is 0.06 kilogram. Then, ang sabi, pag tama daw or pag tira nung raketa dun sa bola, okay, nagkaroon na sila ng contact. Ayan na yung raketa mo, side view. So, ito yung bola. Ayan yung handle na raketa. Okay. Sundan natin Gagandahan ko lang ulit yung drawing. Ayan na yung ating bola at saka raketa. Nagkaroon na ng contact. Okay. So, at the moment daw na tinamaan ng raketa yung bola. So, ang naging velocity daw ni bola is what? 55 meters per second. Tama? At daw yung period na nagkaroon ng contact yung bola at saka yung raketa is 4 milliseconds. Okay? So ngayon, ang tanong sa atin, estimate the average force on the ball or yung in-apply na force nung raketa dun sa bola. Okay? So we have the net force is equal to change in momentum over difference in time, di ba? So we have mv2 minus mv1 all over delta t or change in time. Okay, so we have now what is the mass? The mass of the object that is being hit. Yung pinag-uusapan natin is yung bola, no? Yun yung nagkaroon ng velocity. So, ang mass daw nun is 0.06 kilogram. Okay? Then, yung velocity niya, final velocity is 55 meters per second. Final, Then, mass ulit niya, same object, 0.06 kilogram. Then, yung kanyang velocity is what? Tandaan natin, kapag ka nagsaserve ng tennis ball, di ba, sa serve niya, ito yung bola mo, i-itcha mo muna pataas yan, di ba? Ngayon yan, in-assume natin na titirahin nung tennis player pag hinto. Diba, i-itcha niya, tapos titirahin niya pag hinto sa ere. So, kung hinto yan sa ere, ibig sabihin, ang velocity niya dyan, or yung initial velocity niya is 0. Okay, doon niya kasi titirahin, doon sila magkakaroon ng contact. Tama? Rocket yan, ha? Hindi lang halata. Bawa ito, ayan. After nung contact nila, nagkaroon ngayon ng velocity. So, ito yung iyong final velocity. Okay? So, you have now the initial velocity equal to 0. Okay? All over delta t, or yung difference in time. So, we have 4 times 10 raised to negative 3 second. No? Kasi 4 milliseconds yan. So, we have now, gamit ang calcu, okay, pitutin lang natin. So, we have, cancel na to, no? So, ito na lang. 0.06 times 55 meters per second all over 4 times 10 raised to negative 3. So, that is equal to 825 Newton. So, this is 825 Newton. Okay? So, yan yung force na in-apply dun sa rocket. Ang follow-up question ngayon, enough daw ba yung force na in-apply para makabuhat ng 60 kg person? How we're going to solve for that or to check? So, para malaman natin, solve mo yung weight ng person. So, you have mass times gravitational acceleration. Then, mass ng person is 60 kg. Then, yung ating gravitational acceleration, 9.8 meters per second. So, we have now 60 times 9.8. So, this is 588 Newton. So, obviously, mas malaki yung force na ito. No? Mas malaki yung force na in-apply dun sa rocket. So, kayang-kayang makabuhat nun. Kaya lang, this force, tandaan natin, is this force happened for just 4 milliseconds, no? Napakabilis lang nun, ano? Siguro yung force na yan, kaya niyang paggalawin ito. Itong ating person, ano? Pero kung ang tatanungin, enough daw ba yung force? No? Oo, kaya niyang paangatin yan. Okay? So, another example. So, washing a car, momentum change and force. Okay, water leaves a hose at a rate of 1.5 kg per second with a speed of 20 meters per second and is aimed at the side of a car which stops it. What? That is, we ignore any splashing. But what is the force exerted by the water on the car? Halimbawa, ito daw yung salamin ng kotse. Diba? Tapos, ginakarwas mo ngayon. So, i-assume daw natin na yung tama ng tubig is horizontal, ano? Lumalabas nga yung tubig dyan. Okay? Assuming na horizontal yung tama. Okay, syempre, pag tama ng tubig dito, ano nangyayari? Diba? Nalalaglag na lang. Ibig sabihin, kung initially dito, meron siyang velocity. No? Pag tama niya daw dito, nawawala yung velocity ng tubig. Or naiiba yung direction niya. So, sabihin natin, yung V2 natin dito, 0. Okay? So, ang tanong, what is the force exerted by the water on the car? Okay, so we have now, so the summation of forces is equal to delta P over delta T. Actually, baliktad itong tanong, what is the force exerted by the car on the water? No? By the car on the water. Siyempre, siya yung mag-exert eh. Siya yung magpapatigil ng tubig. So, we have now, so initial, or MV2 minus MV1 all over delta T. So we have the 1.5 kilogram per second. No? So yan yung mass niya kada segundo. So if you're going to consider every second meron lumalabas na ganito, so time natin is 1 second, di ba? So ang kanyang mass every second, no, is 1.5 kilogram. Okay, so if we're going to consider now, so 1.5 kilogram times what is your final velocity? So 0 minus your mass again, 1.5 kilogram times your initial velocity, which is 20 meters per second. Meters per second. Then you have time, sabi natin, consider natin, is 1 second. Okay? So pindutin lang natin sa calculate. So 0, mawala na yan, 1.5 times 0. So we have now negative 1.5 times 20 all over 1. So we have negative 30. So the force applied by the car on the water is negative 30 Newton. So ibig sabihin lang nito, yung force na ina-apply ni, diba, bawa ito yung surface nung sasakyan. So ito yung tama ng tubig, yung force ni water. Tapos ito yung force na ina-apply ni sasakyan, no? Ibig sabihin, yung force na i-apply o yung ito yung velocity ni water, di ba? Yung velocity or yung force na in-apply ni sasakyan is opposite ng direction dun sa velocity. Kaya nag-negative yung ating force. Okay? Tuloy tayo. Okay. So let's have now conservation of momentum, no? Okay. So kung sa energy, work and energy can be conserved, meaning no losses, di ba? Along the system, no? So sa total mechanical energy ng system after and before and after, wala daw loss, no? Pero in practical, meron talagang loss. Kaya lang conserve pa rin siya kasi some of the energy is converted into another form lang naman, no? So dito rin sa ating momentum, okay, it can also be conserved. Halimbawa kasi, two objects, no? Ito kasi yung momentum, gaya ng sabi ko, ito tungkol sa mga object na nagbubungguan, no? Halimbawa, mayroong dalawang object A and B. Imagine natin billiard ball yan, no? So magbubungguan sila. They have both momentum, ano? Syempre, para sila magbungguan, i-ano natin na yung kanilang direction is in opposite, ano? Ngayon, the very instant before sila magbunggo, no? Consider natin yung momentum na yun. For example, ito. Okay? So, sabi kasi dito sa conservation of momentum, if there is no other external force acting on the system, the momentum is conserved. Ano ibig sabihin nun? So, ito, i-consider natin yung moment, the very instant before and after sila mag-collide. So, halimbawa, konting oras bago sila magbungguan, ano yung momentum nila? For example, ito. Kasi kung i-consider mo yung moment na nandito sila sa part na yan, halimbawa, nasa surface sila, di ba? Merong friction, no? So, mabawasan yung momentum nung bawat isa. Pero kung i-consider natin yung moment or consider nating instant, yung bago very instant bago sila mag-collide, so wala nang losses doon, no? Relative dun sa very instant din na after nila mag-collide. Kasi di ba, bago sila mag-collide, yun ang kinonsider mo. So yun na yung last point, no? Bago sila mag-collide. So after nila magbungguan, yung instant na nagbago yung speed ng bawat isa. Okay? So, wala pang losses doon dahil hindi pa sila masyadong nakakagalaw pala. Meron man, maliit lang yung losses. Unlike kung halimbawa, i-consider mo yung point na ito, nakagulong na yung dalawang bola, dumaan na naman sa surface. So, may friction na naman. So, kung may friction, so may losses ulit. Kasi meron na external force na nag-act doon sa dalawang object. So, kaya, ang kino-consider natin dito is yung moment before and after sila mag-collide. No? The very instant. Yung mabilis lang na pagkakataon na yan. Okay? So, kaya, so we have the total momentum of the system before the collision is equal to MA times VA plus MB times PB is equal to the momentum after, no? So actually, kapag ganon, meron tayong several objects involved in the system, you can get the total momentum of that system by simply adding those individual momentum. I-add mo lang yung momentum ng bawat object na involved dun sa system. So you have object A and B. So you add the momentum of those objects. Okay? So kung di naman siya nag-move initially, isi-zero mo lang, di ba? Then after momentum, madalas ang gamit nating symbol is prime, ano? No, meron lang apostrophe, di ba? Or kung tawagin dito yan, MA V prime A, no? So V prime, ano? Ibig sabihin yan after the collision. Okay, kung dalawa yung object mo, you can use A and B. Or kaya naman 1 and 2. Kaso ang ginamit natin kanina for final and initial, di ba? Ayan. 1 and 2, no? So pwede rin ang gamitin mo MV, kung isang object lang naman, MVA prime tapos MVA. Okay? So this means so kapag wala kang prime, initial yan. Okay? So we have now the law of conservation of momentum. The total momentum of an isolated system of objects remains constant. So kung ano yung total momentum nila before sila mag-collide, yun lang din yung kanilang momentum after nila mag-collide o bungguan. Okay? Although, mamaya sa energy natin sabihin yan, ano? Dahil dyan, solve muna tayo ulit. Okay? Okay, another example. Okay, so a 10,000 kilogram railroad car A traveling at a speed of 24 meters per second strikes an identical car B at rest. If the cars lock together as a result of the collision, what is their common speed just afterward? Okay, so meron daw dalawang railroad car, so si A and B. Ngayon daw, si railroad car B is at rest. Sila ay identical, ibig sabihin they have the same weight or mass, no? Para dito sa problem na to. So, ang nangyari daw, tinamaan daw ni railroad car A si B, no? Or sabihin natin car A si car B. At it has an initial velocity of 24 meters per second. So, what is their common speed just afterward? No? Kasi, bakit tinanong what is their common speed? Kasi yung dalawang sasakyan, car A and car B, after the collision, magkadikit na sila or magkasama na. Or sa madaling sabi, they are moving with the same velocity. So we have now, okay, so the momentum before is equal daw sa momentum after. Tama? So we have the mass ni car A times velocity ni car A, diba? Plus mass ni car B times velocity ni car B, equal daw yan sa mass ni car A times yung final velocity ni car A plus mass ni car B times velocity ni car B after the collision. Okay? So, pansinin, ano? Ang condition daw dito, nagkadikit sila, no? So, after the collision, yung ating dalawang object ay isa na lang. And they have the same velocity. So, we have the V prime, ano, para sa velocity nila is equal daw yan kay VA prime equal din kay VB prime. O yung velocity ni car B. Kasi magkadikit na sila, no? So, equal na yung velocity nilang dalawa. So, if we're going to factor out daw, and also, if we're going to consider the velocity of the car B before the collision is 0 kasi at rest. So, ika-cancel na natin to. 0 daw yan. So, we have now MA VA is equal to meron na tayo ngayong MA times B prime, diba? Ito. Plus MB times V prime. So, factoring out V prime, so we have MA times VA is equal to MA, so factoring out V prime, ano? So, V prime now times or quantity MA plus MB. Okay, ang hinahanap sa atin is the velocity of the boat, no? Their common velocity or speed after the collision. So this is the value we are looking for. So solving for V prime, divide both sides by the sum of their masses. Okay, so we have now V prime is equal to MA times VA for the initial velocity of car A all over MA plus MB. So we have, what is MA? 10,000 kilogram. 10,000 kilogram. 10,000 yan, ha? Times the velocity is 24 meters per second. 24 meters per second. All over. So we have two cars, di ba? And identical daw sila. So 2 times 10,000, di ba? Kilogram. So pindutin natin sa calcu. So we have 10,000 times 24,000, 24 meters per second, sorry, all over 2 times 10,000. So that will be equal to 12. Okay, so the velocity or the common speed is 12 meters per second. Okay, so ganun lang. So another example. So conservation of momentum ba rin. So we have a rifle recoil, ano? Calculate the recoil velocity of a 5 kg rifle that shoots a 0.02 kg bullet at a speed of 620 meters per second. So halimbawa ito kasi, di ba? Bago kasi pumutok yung barrel, bawa ito yung part nila na may contact sila. Bawa ito yung bala. Teka, paano ba ito-drawing to? Kailangan maganda yung mukha na bang bala? Bawa, yan yung bala ng rifle. Tapos ito yung part nung ayan yung rifle natin, ha. Tapos, ito yung part ng rifle. So, yun yung bala. Tapos ito yung rifle natin. Part ng rifle at na may contact sa bala. Okay? So, kasi initially, ang mangyayari dyan, pagka kinalabit na yung gatilyo, may pipitik na part dito. No? So, magtutulakan. So, initially, ang mag-apply ng force is si rifle. Okay? Bullet. Ngayon, ang mangyayari dito, sisindi yung nasa loob niyan, may pulbura. Kakaroon na ignition. So, ang mangyayari, itutulak ngayon nito. Yung ating pulbura sa loob, kakaroon ng chemical reaction. Diba? So, magiging energy yun. Mako-convert yung chemical energy ng pulbura. So, magiging kinetic. Tutulak ngayon, ano? May tutulak ngayon ito. Okay, magtutulakan sila. So, after daw nila magkaroon ng contact o mag-apply ng force sa bawat isa, para silang nagbungguan. Kumbaga, si 5 kg rifle, kung dito yung initial niya force, yung magiging velocity niya, ang magiging movement niya, paatras, di ba? Kaya yung mga baril sa pelikula, makikita natin yung parang pinipigilan pa, di ba? Kasi nagkakaroon ng velocity paatras yung, or nagmo-move paatras yung ating baril. Recoil ang tawag doon, pumipitik, di ba? So, yung velocity ni rifle, going to the left, and yung velocity ngayon nung bullet, going to the right. VB and VR. Okay, so initially, so ito yung final velocity nila after the collision. Then, we have the initial. Okay. So, parehas, yung ating rifle at saka yung ating bullet, okay, at rest. So, they are both 0 meters per second ang kanilang velocity. Okay. So, now, ang hinahanap natin is what is the speed of the recoil of the rifle. So, we have now MA. Kambal ba MA pa rin? Solve natin, ha? So, we have mass ng rifle, velocity ng rifle before the collision, mass ng bullet, velocity ng bullet is equal to mass ng rifle, velocity ng rifle after the collision, plus mass ng bullet times velocity ng bullet after the collision. So, ito daw VR at VB or velocity ni rifle at ni bullet is pares na 0. Kasi at rest sila, no? So, meron tayo ngayong 0 equals MR o mass ni rifle, velocity ni rifle after the collision plus MB, velocity ni bullet after the collision. So, ngayon, ang hinahanap sa atin is velocity ni rifle. So, solving that, we can transpose sa kabila yung momentum ni bullet after the collision. So, we have MR VR prime is equal to negative MB VB or V prime B. So, i-consider natin na yung lahat ng pakanan is positive and lahat ng kaliwa is negative. So, positive itong ating velocity ng bullet. So, we have negative MB over V prime B, you know? Didivide natin ngayon both sides by mass ni rifle to solve for VR prime or yung velocity ni rifle after the collision. So, substituting the values now, we have the negative mass ni bullet is 0.02 kilogram. Then, yung velocity ni bullet after the collision daw is 620. You know. So, we have 620 meters per second. Then, mass ni rifle is 5 kilogram. So, that will be equal to, so we have negative 0.02 times 620 meters per second all over 5 kilograms. So, that is equal to negative 2.48. Negative 2.48 meters per second. Okay. So, tama lang kasi in-assume natin na lahat ng pakanan is positive and pakaliwa is negative. Remember, that is a velocity, no? May direction yan. Ngayon, dito, ang nangyari, si bullet daw, pakanan. And, ginawa natin pakaliwa si rifle. Kaya siya nag-negative. Pero kung ipabalik-tarin mo yung senaryo, lalabas lang na in opposite direction lagi si rifle kay bullet. Okay? Okay, tuloy tayo. So we have now collision and impulse, ano? So ang sabi daw, during the collision of two objects, no? Bawa, yung racket tsaka bola ulit, tennis ball. So between their collision or the moment, the time of their collision, delta t. So yung ating force daw dyan, jumps from 0 to maximum hanggang mag-0 ulit. Okay? So that, ibig sabihin, kung yung ating force, okay, between the two objects, jumps from 0 to a certain force, no? A certain value of force, then back to 0 again. So, hindi constant yung force na ina-apply ng bawat isa. Okay? So, ito yung part na kakaano lang nila, no? Kakabangga lang nila sa bawat isa. Then, maabot nila yung maximum nila. Then, dito sa point na to, ibig sabihin, nagkabanggaan, after nila magkabanggaan, no? Magkakaiba na sila ng direction. Okay? That is if the collision is head on, ano? Or yung sapol na sapol yung pagkakakollide nila. Okay? So we have now, okay, so from the equation of momentum or the change, the force, no, required to change the momentum of an object, F is equal to delta P over delta T. So if we're going to cross multiply, F times delta T now is equal to delta P. So ito daw, F is equal to delta T. So that is what we call the impulse. No? Or also, that is the change in momentum. So this is also equal to delta P. The change in momentum, that is impulse. No? Okay? So mag-solve ulit tayo. Magana ba ito? Magana naman. Okay, we have the karate blow, no? Estimate the impulse and the average force delivered by a karate blow that breaks a board. Assume the hand moves at roughly 10 meters per second when it hits the board. So, change in momentum lang, di ba? Before siya mag-hit sa board, ito yung kanyang velocity. Okay? Then, after niyang mag-hit, okay, 0, syempre. Hihinto siya doon. So, we have the change or we have the impulse. Kasi hindi available yung ating force, no? Force and delta T. So, we can use delta P na lang or change in momentum. So, we have delta P. So, that is equal to mv2 minus mv1. Diba? Yung ating okay. Okay, so i-estimate natin ngayon, 'di ba, yung impulse. So sabihin natin 1 kg yung mass ng kamay, ano? So we have 1 kg. So yung final velocity niya is 0, 'di ba? Kasi hinto siya sa part na tamaan niya na yung plank or yung board, di ba? So yung initial velocity niya meron niya. So 1 kg times yung initial velocity is 10 meters per second. So we have a negative 10 kilogram meters per second. Okay, so that is actually the unit of momentum, no? Kilogram meter per second. Okay, so ang sabi, estimate the impulse and the average force delivered by a karate blow that breaks a board. So what is the average force? I-estimate lang din natin. So for example, we use time is equal to 2 times 10 raised to negative 3 second, ano? Estimate lang natin, ganun daw kabilis yung contact nilang dalawa. So the force now is equal to delta P over delta T. So the force, no, delivered by a karate blow. Okay, so we can use, okay, negative 10 kilogram meters per second all over delta T is 2 times 10 raised to negative 3 seconds. So that is equal to negative 10 over 2 times 10 raised to negative 3. That is 5,000. 5,000 Newton. So, ang nakuha nating sagot is negative. Ibig sabihin, in-assume natin dito na yung ating force na nag-apply is yung si board, ano? Yung force na in-apply niya para mapahinto yung kamay. Pero, syempre, equal lang yung force na yan. No? Yung force na dineliver nung kamay dun sa board para mag-break, di ba? Equal lang yan, but in opposite. Therefore, the force is equal to 5,000 Newton, or the force delivered by the karate blow, o yung kamay mismo. No? That is 500 Newton. Okay? Okay, tuloy tayo. Okay. So, we have now conservation of energy and momentum in collisions. So, kagaya dun sa ating work and energy, so energy can be conserved, di ba? Okay. Even if the energy is said to be conserved, like when there's no other non-conservative forces acting on the object, or the realistic conservation of energy, like when an object is subjected to non-conservative forces, energy is still conserved, di ba? But the kinetic energy itself and the potential energy is not conserved, but rather it is converted into another form of energy. However, it is said pa rin to be conserved, no? Kumbaga, yung energy natin, yung kinetic and potential, hindi na natin nako-conserve. Nata-transfer na siya into other form of energy. Pero yung total mechanical energy of the system, yun pa rin, no? Pag-transfer niya dun sa final position, no? Yung ating mechanical energy na bawasan na. So, kasi yung ibang energy, na-convert lang into another form. Kaya ina-add natin, bawa yung work done by the friction, no? Okay, so dito sa momentum, we can use then the conservation of kinetic energy and also potential energy, no? We have that so-called elastic collision, no? Ang sabi, if the the total kinetic energy just after the collision, and they are found to be the same. Okay, if we compare the total kinetic energy just before the collision with the total kinetic energy just after the collision, and they are found to be the same, then we say that the total kinetic energy is conserved, no? Such a collision is called an elastic collision. Okay, so sa theory, ito yung wala daw na sasayang na energy, walang natatapon. So, kung ano yung total kinetic energy ng dalawang object, di ba? So, meron tayong object 1 and object 2. So, ang i-consider, bago sila mag-collide, no? So, yung very instant na bago sila mag-collide. So, yung total kinetic energy is equal sa total kinetic energy after nila magbungguan. So, yung energy ni A, kinetic energy ni ball A, tapos yung kinetic energy ni ball B, no? Kunin mo yung sum, equal lang daw yon sa total ng kinetic energy after nila magbanggaan. So, that is what we call the elastic collision daw, no? Ngayon, kagaya lang din sa energy, di ba? Hindi naman talaga how do you call this? Yung kinetic energy or yung potential, no? Yung total kinetic energy ng dalawang object o yung total kinetic energy ng system after the collision, hindi naman na hindi naman na daw equal talaga yan. Ibig sabihin, meron nang nabawas or it is not conserved. Kinetic energy is not conserved. Okay? So, in the process of collision kasi, so, ang nangyayari, di ba, nagkakaroon ng change ng energy, no, ng form ng energy. Yung ibang kinetic energy na co-convert into heat or thermal energy. No, minsan, a little portion of sound energy, di ba? So, kaya, dito sa equation natin ngayon, so we have the initial or the kinetic energy of the system before the collision, Ke sub A plus Ke sub B, and we have the kinetic energy after, the sum pa rin nila. Then, idadagdag natin yung ibang form ng energy na pinag-convertan nung kinetic. Okay? So, isang sama lang yan, yung form ng energy na yan, kung saan na-convert yung kinetic natin. So, kapag daw ganon, na hindi na-conserve, or the kinetic energy is not conserved, so the collision is said to be inelastic. Inelastic yung collision. Kapag na-conserve, elastic. Kapag hindi na-conserve, inelastic. Okay? So, now, let's have the elastic collision in one dimension. Magana ba? Okay, tuloy tayo. So, elastic collision in one dimension. Suppose we have a collision of two objects in one dimension, di ba? A and B. Babanggaan daw. Okay? So, from our conservation of momentum, we have the momentum before, or the sum of the momentum before, is equal to the sum of the momentum after of the system. Ito yung equation na yan, di ba? Then also from the conservation of energy and momentum, ito yun. Ito yung equation natin, di ba? If we're going to factor out here, for example, let's say the object have the same mass, no? MA and MB. Tandaan, ano? This scenario is for only for those objects that has the same mass. Let's say MA is equal to MB. Okay? So we have now, we're going to cancel MA and MB kasi equal sila sa parehas. Pwede may factor out yan, di ba? So we're going to obtain VA plus VB is equal to VA prime plus VB prime. Tama? Then now, we can transpose, okay, yung velocity ng bawat isa. Before and after. So we have VA minus VA prime is equal to VB prime minus VB. Okay? So now, from equation 2, o to equation na to, ano? Equation 1 yan. Equation 2. So we obtain equation 3. Equation 3. So this is equation 3. Okay? So from equation 2 now, cancel out lang ulit lahat ng mass. Diba? Kasi common daw. Then also yung 1/2. Common sila sa lahat. Diba? Pwede natin cancel. So ang matitira, so we have VA squared plus VB squared equals VA prime squared plus VB prime squared. Okay? So we can transpose ulit yung velocity ng bawat object. So we have VA squared minus VA prime squared is equal to VB prime squared minus VB squared. Okay? So from that, okay, that is equation 4. So we can divide now equation 3 by equation 4. Or equation 4, we can divide that by equation 3. Okay, so we have now VA squared minus VA prime squared is equal to VB squared minus VB prime. So we divide this by equation 3. Diba? What is our equation 3? VA minus VA prime is equal to VB prime, VB prime minus VB. Parang baliktad ginagawa ko dito. VB prime, VA squared. Okay, baliktad nga. Baliktad na gawa ko dito. So this should be VB prime squared minus VB squared. Okay? Galing dito. So now, alam natin na ito, pwede nating i-factor out to into VA plus VA prime times VA minus VA prime. Diba? Is equal to VB prime minus or plus VB times perfect square yan, diba? Pwede natin opposite sign, So VB prime minus VB all over VA minus VA prime. So ito all over VB prime minus VB. So we can now cancel common term, So VA minus VA prime common dito. Then we have also here, can cancel out this. So matira sa atin VA plus VA prime is equal to VB prime plus VB. So we can use this equation, Ngayon, meron daw expression na nabuo dyan. Okay? So if we're going to transpose yung mga VB sa kabila, plus yung VA sa kanan. So we have na VA minus VB is equal to VB prime minus VA prime. Okay? So ngayon, i-ano lang natin, VA minus VB. Factor out natin yung VA, ayan, minus VB. Siyempre, prime to parehas. Okay, meron tayong nabuong equation or expression, So ito daw, ibig sabihin daw yung relative velocity, nung dalawang object is equal lang, before and after. Yung difference nila before sila mag-collide ay equal lang dun sa difference ng dalawa after nila mag-collide. Kaya lang, in opposite direction na, syempre. Kasi, kapag ka daw same mass yung dalawang object, ang mangyayari daw dyan, same mass sila, magkabungguan, at the moment after nila mag-collide, yung kanilang direction is magkakapalit and magkakaiba lang ng direction. Yung velocity ng dalawa, magkakapalit daw yan. Okay, pero, conserve pa rin yung kanilang momentum. Okay? Solve tayo. Okay, nuclear collision. Okay. Ito palang example na to conservation of energy and momentum pa rin. Anyways, yung equation na ginamit natin kanina, pwede yun, baka equal yung mass, diba? So now, let's have this, a proton of mass 1.01 U, This is atomic mass unit, U. Okay? Traveling with a speed of 3.6 times 10 raised to 4 meters per second has an elastic head-on collision. So, head-on, ibig sabihin, yung sapul na sapul sila, collision with a helium nucleus. Okay, the mass is 4 atomic mass unit, initially at rest. What are the velocities of the proton and helium nucleus after the collision? As mentioned in chapter 1, okay, assume the collision takes place in nearly empty space. So, meron daw dalawang particle. So, ito si helium. Ito yung helium natin. Tapos, ito yung proton. Okay, ang mangyayari daw dyan, magbanggaan silang dalawa. Si proton, babanggain niya si helium. And si helium is initially at rest. So, velocity ni helium, initial velocity ni helium is 0. Okay, si proton daw, ang kanyang initial velocity is equal to 3.6 times 10 raised to 4 meters per second. Okay. What are the velocities of the proton and the helium nucleus after the collision? Okay, so we can use conservation of momentum. Okay? Kasi wala namang ibang force na nabanggit na in-apply dun sa dalawang object. So we have now conservation of momentum. So we have the mass of proton times velocity ni proton plus mass ni helium, velocity ni helium is equal to mass ni proton, velocity ni proton after the collision plus mass ni helium, velocity ni helium after the collision. Ang hinahanap sa atin, velocity nila ng dalawa after the collision. So, dalawang unknown, ano? So, itong ating velocity ni helium before collision is 0 kasi at rest siya. So, lumalabas, dalawa yung unknown. So, kung dalawa yung unknown, we need at least 2 equations. So, since yan ay head-on collision, so we can use yung equation nating nakuha kanina. Diba? Yung VA minus VB is equal to VB prime minus VA or VA prime or negative VA prime minus VB prime, di ba? To VA minus VB. So, assume natin yung dalawang object natin magko-collide. So, yung VA natin is VP, no? So, VP minus VB or yung velocity ni helium is equal sa velocity ni helium after collision minus velocity ni proton after the collision. So, yung velocity ni helium before the collision is equal to 0. Okay? So, we have now, we can solve for VHE or yung velocity ni helium. Velocity ng helium after the collision is equal to, transpose lang to sa kabila. So, we have VP plus VB prime. Okay? So, meron na tayo ngayon pwedeng substitute. Okay. So, ito yung ating equation 1. And this is our equation 2. So, we can substitute now equation 2 in 1. Okay? Pasok natin yung value ng VHE na yan. So, we have now MP VP is equal to MP VP prime plus MHE or mass ni helium times what is the value of VHE. So we have VP plus VP prime. So we're solving for VP prime now. So meron tayo nung velocity in proton before the collision. So we have now we can distribute first this. Okay. So we have MP VP is equal to M. What is this M? MP also. Sorry. So this is MP VP prime or the velocity of proton after the collision. Then distribute this one. So we have MHE or mass ni helium times the velocity of proton plus mass ni helium times velocity ni proton after the collision. So transpose this. Ang titira lang lahat ng may VP prime. Then factor out VP prime. So we have now this two term. Factoring VP prime or the velocity after the collision. So we have MP plus MHE. So this will be equal to MP VP minus MHE or mass ni helium times velocity ni proton. Okay, so we can divide both sides by MP plus MHE. Okay, so we have MP plus mass ni helium. Okay, so velocity now ni proton after ng collision. So we have mass ni proton. What is mass ni proton? 1.01 U, di ba? 1.01 U times velocity ni proton is 3.6 times 10 raised to 4. Tama ba? Okay, meters per second minus mass ni helium is 4 U. 4.00 U per atomic mass unit, no? Times velocity again ni proton is 3.6 times 10 raised to 4. Then sa ilalim 1 U, 1.01 U plus 4 U, no? Factoring, actually hindi na natin kailangan i-convert ito into kilogram. Bakit? Kasi maka-cancel out lang din. You have U, no? You can factor out U sa taas and sa baba. Then cancel it out. Diba? Pag kinonvert mo, ganun lang din yan. So factoring out U, cancel na, no? So this, those are just factors, no? So we have now here. So we have 5.01. Okay. So we have 1.01 minus 4, that is 2.99. So we have negative 2.99 times 3.6 times 10 raised to 4 all over 5.01. So this will be V prime, or the velocity of the proton after the collision. So this is equal to negative 2.99 times 3.6 times 10 raised to 4 all over 5.01. So this is equal to negative 21,485. 21,485.03 meters per second. So ibig sabihin, nag-negative siya. In-assume natin na lahat ng in-assume natin kasi pakanan si proton, no? Yung initial na velocity niya. Okay? So kung pakanan siya initially, after ng collision daw, magiging pakaliwa na siya. And si helium naman, so kung ideally, kapag binangga ng object na to, pakanan tong object na to, magiging pakanan din yung kanyang velocity. At ito, magiging pakaliwa na. Diba? So, given that helium is initially at rest. So, substituting the value of Vp prime here. So, we have Vp prime, by solving for Vp prime. So, from here, so Vp prime, okay, so we're solving for Vh pala, no? Vh prime. So, Vh prime, or the velocity of helium after the collision, we have Vp plus Vp prime. So we have Vp is 3.6 times 10 raised to 4. Then we have negative 21.49 na 21.485 na lang gawin natin times 10 raised to 3. Tama ba? Okay. So solving using our calculator. So we have 3.6 exponent 4 minus 21.485 times 10 raised to 3. So we have 1.42. Sabi? 1.45 pala. 1.45 times 10 raised to 4 meters per second. So yun daw yung magiging velocity ni helium after nila mag-collide ni proton. Okay. So, tuloy tayo. Okay. So, we have now inelastic collision. So, ang sabi, kapag daw hindi na-conserve yung energy ng isang object or ng system, yung kinetic energy ay hindi na-conserve, that is what we call inelastic collision. No? So, natatransfer lang daw into another form of energy. No? Kaya siya na hindi na-conserve. Pero, okay, yung kapag yung dalawang object, bawa ay nag-collide sila, nagkapungguan, tapos nagkadikit na, no? Okay, yun ay tinatawag natin completely inelastic. Okay, kapag nagkabungguan, di ba? Object A, tapos object B. Initially, diba, gumagalaw sila parehas. Tapos, after the collision, after. So, we have, magkadikit na yung ating A and B. Isang object na sila. Anong ibig sabihin yan? Yung dalawang mass nila, magkukunin mo na isang. Tapos, isa na lang yung velocity nila. Okay, they are moving at the same velocity now. Okay? Gumagana ba? So now, solve tayo ulit. Tapos, lapit na matapos. Okay. So we have now ballistic pendulum, no? The ballistic pendulum is a device used to measure the speed of a projectile, such as a bullet. The projectile of mass m is fired into a large block of mass m, okay, which is suspended like a pendulum. Usually m is somewhat greater than m, yung mass ng ating box and mass ng bullet. Okay, zoom lang natin. As a result of the collision, the pendulum and the projectile together swing up to a maximum height h. Okay, nag-swing daw yung ating pendulum box. Then, determine the relationship between the initial horizontal speed of the velocity projectile B and the maximum height. So, initial velocity daw ng ating projectile. So, yung initial velocity niya. Okay? So, ang nangyari kasi, so we have the initial before the collision. Then, after the collision, magkasama na. Pumaloob dun sa box yung bala. Okay? So, papansin, umangat. So, tatandaan natin, kapag umangat ang isang object, nagkakaroon ng change in potential energy. Okay, so now, so we have the kinetic energy plus potential energy is equal to kinetic energy pa rin after the collision plus potential energy after the collision. So we have here 1/2 MA or yung mass ng ating, sabihin natin mass ng projectile natin, mass ni projectile, tapos yung velocity ni projectile squared plus ano ba yung umangat, ano? So dito, before the collision, okay, so yung potential energy natin 0 kasi pwede reference natin, di ba? Tama? So, meron pa ding, may kinetic energy din to, ano? So, actually, ang nangyari dito, sum ng kinetic energy ng dalawang object. So, we have 1/2 mass ni, mass ni box or ng pendulum. Mass ng box, lagay natin. Tapos, velocity ng box, initial, squared. Plus, yung potential energy ngayon ng dalawa. Diba, mg or mass ni projectile times g times height ni projectile, initial height niya, plus mass ni box times g times y sub p, y sub b, sorry, or yung position ni box, then equals, yung kinetic energy, same lang din naman. So we have here 1/2 times m nung projectile. Okay, then we have Vp prime squared plus 1/2 mb times Vb prime squared plus yung potential energy, so mass nung box, mass nung projectile G times yung final height ni projectile. Then syempre yung dutuktong ko na dito, mass ni bullet times G times YB prime, yung final position ni box. Okay, so yun lang, ano. Dito ko na ilagay para tipid yung space. Plus MB G Y sub V, or yung height ni bullet. Kasi umangat sila, yung height ni box. Kasi after the collision, umangat, di ba? So ngayon, ano dapat nating pansinin? Yung ating velocity ni bullet, velocity ni box, initially at rest. So ito magsi-0. Then also yung height, kung itong reference natin, di ba, mula dito, yung initial position niya, yun yung ginawa nating reference. So assume na rin natin yung bullet, same height lang sila nung iaangat ng box. Okay? So yung ating initial position, y is equal to 0. So cancel. Parehas yung bullet tsaka yung box. Ngayon, after the collision, ito tayo. So yung mass or yung velocity ni bullet or nung projectile tsaka ni box, parehas na. So we name it V prime. Okay, so V prime daw is equal to velocity ni projectile natin or yung bullet after the collision equal din sa velocity ng box after the collision. And also, kung magkasama na sila, they have the same change in height. So we have H is equal to Y sub T, no? O yung Y nung ating projectile is also equal to the Y nung ating box or yung height after the collision. So we have now 1/2 what is MP or mass ng ating projectile, that is M lang, ano, M. Then yung velocity ng ating projectile before, so let's name it V, di ba? V squared is equal to what is the mass? Okay, 1/2 times yung mass ng ating projectile, then yung kanyang velocity, pangalanan natin na V prime na lang, ano? So V prime squared plus mass ngayon nito, mass ng box is big letter M, so we have 1/2 M V prime squared plus, okay, so factoring, meron na tayong common, ano, so yung mass ngayon ni projectile, small letter M times G times H, ano, yun the Y prime or yung Y sub P or yung Y ni projectile prime or after the collision is H, no, plus mass ni box, no, times G times yung kanyang height after the collision, so Y sub B prime is equal to H pa rin. Okay, so we have now we can factor out this, no, so we have 1/2 MV squared is equal to factoring V squared, no, so V squared or 1/2 V squared, 1/2 V prime squared, so we can factor out M plus M. Okay, so plus we can factor out G times H here, so G times H, so we have M plus M, tama. Then we can factor out now M plus M and 1/2 V prime squared plus G sub GH, no, is equal to 1/2 MV squared or yung initial. So we have equation 1. Kasi ang gustong kunin, determine the relation between the initial horizontal speed of the projectile V and the maximum height H. Okay? So kailangan natin ngayon yung para dito. So equation 1. Kunin natin yung value ng V prime squared. Okay? So kung nagamit natin yung sa energy, pwede rin yung sa ano dyan. Pwede rin yung sa momentum. Okay? So we have mass ni projectile times velocity ni projectile initial plus mass ni bullet mass ni box times velocity ni box. Then yung mga velocity nila after the collision, mass ni projectile times velocity ni projectile after the collision plus mass ni box times velocity ni box after the collision. Okay? So canceling VB kasi ito 0, di ba? At rest initially. Then ito daw, di ba? After the collision, V prime will be equal to VP prime plus VP prime or yung velocity ni projectile is equal din sa velocity ni box kasi magiging isa na lang sila, magkakasama sila eh. Okay, so we can write now what is the mass of the projectile? So small letter m lang daw. And yung velocity ni projectile before the collision, so V. Then here mass ni projectile, small letter m, then V prime, ano? We can replace this by V prime according to this. Then plus mass ni box is big letter M, then VB prime, V prime pa rin. So factoring out now V prime, so we have M plus M. Okay, so solving for V prime, so we have M times V all over M plus M. So we have equation 2. So we can transpose this now here. So we can replace, no? So V prime squared, okay? Substitute lang natin dito. So we have now, substituting the value of equation 2 in 1, okay? So we have 1/2 mv squared is equal to m plus m, okay, times, so 1/2 v prime is, okay, mv m plus m squared plus gh. Okay, so simplifying this, so we have, okay, so sana nasusundan pa, no? So 1/2 mv squared, ba't may squared dito? So mv, tama, mv squared is equal to m plus m. Then we have now, okay, so i-square lang natin yung taas, m squared v squared all over. So ito magiging m plus m squared to, multiply lang natin dito. So we have, okay, so we can multiply the whole equation by 2 plus m plus m. Di ba mamaya, no? So ito, fraction yan, magiging m plus m squared. 2 times m plus m squared. So i-multiply lang natin to dito. Okay? So we have g times h times m plus, so magiging 2gh times m plus m quantity squared all over 2 times m plus m squared. Okay? So we can cancel now yung isang m plus m. So we have now 1/2 mv squared times, okay, cross multiply lang natin to. So we have times 2 m plus m is equal to m squared v squared plus 2gh m, small letter m plus big letter M squared. Okay, sinulak na yung papel. So we have now, we can factor out, ano pwede nating i-factor out dito. So pwede na natin pagsamahin lahat ng magkakamuka. So dito, since ang hinahanap natin is b squared, transpose na natin dito. Okay, so ang hinahanap natin is b squared, so we have now, so ito cancelin na natin to. So this should be not So this is 2m plus m. So makakancel na yung 2. Then transpose natin. So we have now m squared, v squared, okay? Oh, sorry, this is m. M minus, okay, mv squared, kasi natin mv squared minus m squared v squared is equal to, okay, teka, yun, wala yun, so we have m v squared times m plus m, okay, minus, transpose natin m squared v squared plus or equals 2gh times m plus m squared. Okay, so now factoring v squared, so we have v squared times, okay, so m times m plus m minus m squared, okay, is equal to 2gh times m plus m squared. Okay, so anong pwede natin gawin? Okay, so now solving for v squared, so we can divide both sides by this value. Then we get the square root of both sides. So we have now v is equal to the square root of 2gh times m plus m quantity squared all over m times m plus m minus m squared. So mangyayari dito, so pwedeng space, wala na tayong space. Iakat ko lang dito So v now is equal to, okay, the square root of 2gh times m plus m squared over m times m plus m minus m squared. So mangyayari dyan kasi, so ito lalabas lang kasi naka-square, di ba? So yung nasa ilalim, ano mangyayari? So ito m times m is positive m squared. Then meron pa negative, so maka-cancel na. So ang matitira na lang, m times m na malaki. So you have now this value, lalabas yan. So you have m plus m all over times the square root of 2gh all over m na maliit times m. So this is the relation between the velocity or initial velocity of the projectile. Okay, so tuloy tayo na itong solve. Tuloy tayo ng discussion. Saan ba? Okay. So what about when collision in two dimensions? Ano? So dito naman ang nangyayari, ang tama nung object, the place, no? Initially at rest tong B, no? Kaya lang, nung tumama yung ating object A. Okay, gumagana naman. Nung tumama yung ating object A kay object B, hindi niya nasentrohan. The place lang. Ang nangyari, nagkaroon ngayon ng angle yung direction nila. Okay? So we can, since ito ay vector, so we can solve for the px before and after. Diba? Also sa y. Pwede natin i-solve yan using components. No? Solve tayo ng problem. Okay. But may elastic collision pa rin dito. Okay, ito muna solve natin. Inelastic collision pa rin. For the completely inelastic collision of the two railroad cars that we considered in example 7, to calculate how much of the kinetic energy is transformed to thermal or other forms of energy. So, diba, we have KE initial is equal daw to KE final plus yung, sabihin natin Q yung thermal energy, no? yung other form ng energy, no? So, bawas mo lang yung solving for Q, you have KE minus KE prime. Okay? So, dito, yung initial, what is that? So, ito magsi-0, diba? So, you have 1/2 MA VA, okay, plus 1/2 squared, 1/2 MB VB squared minus, okay, yung kinetic energy mo final, so 1/2 VA final squared, okay, after the collision, then plus 1/2 MB VB prime squared. Okay? Ngayon, alam natin nagkasama sila. So, they're moving at the same velocity. So, palitan natin tong VA prime ng V prime. Okay? So, we have na 1/2 MA squared. Tapos ito, 0. Dahil at rest. So, 1/2 MA times VA squared minus, so this will be equal na to. Since magiging V prime sila parehas, pwede may factor out yung 1/2 V prime squared times MA plus MB. So kanina, nasolve na natin yung V prime niyan. Huwag natin solve ulit. Balikan na lang natin. Ano yung V prime? So may dalawang trend yun. Okay, 12 meters per second. Siguro gamitin natin 12 meters per second. Ilang din na may problem. Ang tanong lang, ano yung energy ay na naging init, ano? So, due to friction, kaya naging init. So, you have Q is equal to 1/2. What is MA? So, 10,000 kilogram. Then, yung velocity niya initial is, ano na nga yun? Balikan lang natin. So, velocity niya initial is 24 meters per second. So, 24 meters per second squared minus 1/2 times 12 meters per second. Ito yung velocity ng train ng dalawa after meters per second squared times 10,000 plus 10,000. So, solving now. Okay, calculate natin. So, we have 1/2 times 10,000 times 24 meters per second squared minus 1/2 times 12 meters per second squared times 10 times 10 plus 10, 10,000, diba? So, we have 20,000 kilogram. So, we have 1,440,000. So, we have Q is equal to 1,440 kilojoules. So, that is the amount of energy converted into or transformed into a thermal or other forms of energy. So, tandaan, kapag meron tayong inelastic collision, i-add mo lang dun sa final or yung sa after collision yung other forms of energy. Kasi yung iba nga nito, naging heat, no? Naging other form ng energy. So, ngayon dun tayo sa 2 dimension. Okay, billiard ball A moving with speed of 3 meters per second. Ito yun. Ito yung nag-move ng VA is equal to 3 meters per second. In the x direction, strikes an equal mass ball B. Parehas daw sila ng mass. Initially at rest. The two balls are observed to move off at 45 degrees to the axis. Ball A above the x-axis and ball B below. That is angle theta after angle theta A after the collision 45 degrees and theta B prime negative 45 degrees. Okay, what are the speeds of the ball after the collision? So Si A daw, hihit niya yung ball B na nakarest. Ngayon, after the collision, yun daw velocity ni A directed 45 above the x-axis. And ito naman, 45 below. Okay, so x component muna. Okay, so we have the x component ni A. Baliktad yata yung sulat. Or yung momentum, no? Momentum ni A along x-axis plus momentum ni B along x-axis is equal to a momentum ni A after along x-axis, okay, plus momentum ni B after the collision along x-axis pa rin. So we have now the velocity, no? So VA, so this is along x, no? So VA now is also equal to VAX. Okay, so we have the mass times the velocity, no? The mass of ball A times the velocity of, or the x component of the velocity, plus mass ni ball B times the velocity of ball B before the collision, of course, x component. Okay, and then yung ating after the collision, mass ni ball A, velocity niya after the collision, syempre x component plus mass ni ball B times velocity ni ball B after the collision, x component pa rin. Tandaan natin yung ating ball B initially at rest. So ito, magsi-zero yan. So we have now, ang hinahanap sa atin is yung x component, no? Dito sa ating x-axis, dalawa yung missing x component din, no? So pero kung tutusin, okay, so yung dalawa na yan, parehas ng angle, di ba? Okay, so VA, so we have VA, so this is 45, and this is VA. So VAX will be equal to, VAX is equal to, okay, so VA cosine 45. Okay, palitan natin ngayon. So ito naman, so VBX, so this is equal to VB cosine 45 lang din. Kaya lang, okay, since yan ay x-axis, pare silang pakanan, pare sa positive. Ngayon, alam natin that pare sila ng mass, okay, parehas lang ng value yung cosine 45, di ba? So we have now MA VAX, or also VA kasi puro x component lang yan. VA is equal now to MA times VA cosine 45 plus MB VB cosine 45. Okay? Okay. So meron tayo ngayong nabuong equation, equation 1. So para sa x-axis to. Ang hinahanap natin is yung VA final, ano? And VB final. Okay? So, ginawa ko na silang yung actual na velocity ng dalawang object. Okay? Hindi na yan x and y component. Kasi, minultiply natin ng cosine 45. O, sa y-axis naman tayo ngayon. Okay? So, same pa rin. MA VAY plus MB VBY is equal to, after the collision, so MA VA prime Y plus MB VB prime Y. Okay? After the collision, so yung ating MA, yung ating VA initial, wala siyang Y component, so ito ay 0. Siyempre, itong ating VB initially not moving, so VX and VY niya ay 0. Okay? So, matira lang sa atin ito. So, from here, di ba? 45. Ito yung ating VA. Ito yung VAY mo. Ito yung VAX. Solving for VAY, you can use sin theta. Di ba? VA, okay, is equal to sin theta. So, VAY is equal to VA times sin theta, which is sin 45. Kaya ngayon, so we have 0 is equal to MV VA prime sin, times sin theta or sin 45. Ngayon, nakita natin isang pataas, isang pababa. So, ini-negative lang natin ito isa. So, yung ating sorry, ba naging MB ito? So, this should be MA. MA. So, yung ating MB o yung ating mass B. So, BB prime, pababa siya. Base dito, pababa yung direction niya. So, ini-negative natin. So, we have BB prime sin 45 pa rin. Kasi yung sin 45, mag-ano lang ulit yan, positive, no? So, iset natin na negative. So, we have na equation 2. Equation 2. So, we can eliminate, no? Or we can substitute, no? So, ito, madaling-madali ito sa calculator. Kasi yung isa nating equation, ito, equation 1 and 2. So, we can cancel out VB, no? Or kaya naman, VA, nasa inyo. Pero ako, gusto ko dyan, gawin ko, equal sila ng mass, di ba? Okay. Sabi, 2 balls observed to move. Okay. Moving with the same, with the speed. Okay, strikes. Equal mass. Okay. So, kung equal daw yung mass, cancel na natin yung mass. Ganon din dito. Cancel na yung mass. Okay, so we have now VA is equal to VA prime cosine 45, di ba? Mas madali. Plus VB prime cosine 45. So, yan yung equation 1 natin kanina, di ba? Then, 0 is equal to VA prime sin 45 minus VB prime sin 45. Okay, yun yung equation 2. So, we can eliminate, ano? So, pero ako, gusto ko gamitin ko na lang calculator method. Okay, so punta tayo sa equation. Ano na nga yung speed niya, initial speed? So, 3. Meron tayo equation 2 unknowns. Okay, so kailangan natin dalawang equation. Okay, equation 1. Ito yung x natin, di ba? Ito yung x, ito yung y. Sa unknown, sa unknown. Hindi sinabing component. Okay, we have cosine 45 daw. Then, yung coefficient ni VB prime, cosine 45 din. Kaya yan dito. So, that is 3 meters per second. Okay, so 3. May natin 3. Okay, then dito, so sin 45. Tapos, negative sin 45. Tapos, yung constant natin, 0. So, pindot lang. So, we have x or VA. Yung sinet natin x po, x dun sa missing, di ba? VA prime is equal to 2.12. 2.12 meters per second. Positive, no? Then, we have y or VB. VB prime is 2.12 also. Positive din. Bakit? Tandaan mo, yan ay horizontal na, no? Horizontal direction yan. So, magpa-positive talaga yan. Doon lang tayo, since vector yan, doon lang tayo magkaka-negative sa x and y component. Pero sila, equal. Okay? So, balik tayo sa PowerPoint natin. Oh, yun na lang pala. So, yun lang. Sige. So, sana nasundan. Okay?